recording. Okay. So we're talking about system variables today. And so last week we learned how to create variables. But today what we're going to look at are system variables. This is a term that refers to variables that P5 creates for us. So we've seen the functions set up in draw already. And so we know that there's certain parts of our program that P5 makes for us and calls for us. And P5 also makes some variables available to us. And so we're going to take a look at what those variables are and how we can use them to update our sketch. First, we're going to review setup and draw a little bit and go over some stuff that we may not have talked about before, just to kind of review, but also talk about the difference of these two functions. So just to review, so setup is going to happen once when we start our program. And typically, we're just going to have one line of code that we need to have in there, which is the create canvas. And that makes the canvas that we're going to draw on when we start our draw function. And the reason we do that is because we only want to create one canvas. We only need one canvas to draw on. And so if we had this create canvas function inside of our draw function, we'd have a problem where we'd be creating, 60 canvases per second, and they'd all be drawing one frame, which is not what we want. So in setup, we're going to do things that we just want to happen once to get ready for our program. And then draw, remember, is running 60 frames per second. So that's how we can render animation, and that's how we can render interactions as well. And so to quickly demonstrate the difference, I'm going to use a system variable here that we haven't actually talked about yet, but you'll see it'll be pretty obvious what it does. So if we have a background, and I'm going to draw an ellipse, and if I draw an ellipse at 0, 0, and let's make the width 100. So you'll see we can only see a little slice of the ellipse because we're drawing it up at the top left corner. And it looks like it's just staying in one place, right? And we can move the ellipse. If I change one of these numbers, like if I change y to 100, it's going to move the ellipse down the page. Or if I change it to 200, we're going to move the ellipse down. And it looks like, again, it's just drawing in one place, but that's because these numbers, they don't change at all. If we put in a number that does change, like a variable, so I'm going to use as an example the frame count here. So frame count does kind of what it sounds like. It just counts up every time we draw on our canvas. If I play the sketch now it looks like we have this animation. Our ellipse is moving across the canvas. And it's going to disappear, and then it's not going to come back. And so the x value is changing for as long as the canvas, as long as the program is running, every time this draw function gets called. So if I take out my background, so I hit control and question mark or / to comment out the background. Well, it's kind of hard to see in this current setup, so because I have the dark background. Let me change I'll draw the background once. So let's just draw the background once in setup. So now we'll be able to see this a little bit better. So now you can see the circles actually being drawn over and over again. And the reason it looks like it's moving across the page is because we're covering up the previous circles with the background. So the background covers up the circle that was drawn before. And that's how we get the illusion of motion. And it looks like this big kind of like smear if you were like drawing across a piece of paper, but maybe your hand was, if you're drawing to the left or you're drawing to the right with your left hand and you smeared across the page. We can change this number, like let's say I say frame count times 2. You can see more of the details there. And if I say like times 10, so you can see there's multiple circles being drawn. There's a couple of functions that you can call. So for example, if I say no loop, what this does is it stops my draw. So we also refer to the draw function as the draw loop. And we're going to talk more about other types of loops in a couple weeks. But what that means is it basically it's looping, it's running over and over again. And so if we called no loop, then that stops. We can also change the frame rate if we want to. So if I want to say frame rate, if I want to say like 1, that'll be 1 frame per second. And so we'll see the sketch updates very slowly. The default is going to be 60 frames per second is what it's going to try to go for. But I could also do something like 24 frames per second. These are other functions that are built into P5. And so if I put in my background again, with the change frame rate, now the motion doesn't look as smooth, right? Because we're drawing fewer frames. And we're drawing fewer circles in between those frames. So we have less smooth motion. If I did a frame rate of like 12, you can kind of see it looks like it's moving. If I do like 2, it's going to be super slow. And so, as I've talked about before, if you play video games, you're familiar with the idea of frames per second. And if you're running, a very modern 3D video game on an old system, that frames per second is going to start to slow down. Because the amount of time it takes for the computer to draw all the graphics is greater than how much time you need, like 16 milliseconds or something, to get that 60 frames per second. So we don't have that issue as much with P5 because we're not drawing like super complicated graphics. So it's pretty easy to run at 60 frames per second. And so that's usually what we're going to be doing. So let's take these out. All right, so to review our code scope and our global variables. So we talked a bit about this last week. So remember, last week we started using variables like variable x, variable y to change the position of things. And this is just a reminder that I want to usually put my variables up at the top of my program in what's called the global scope of the program. So for example, if I was doing this without the frame count, if I was saying like variable x equals 0, and then using x to increment here, and then just saying x plus plus, I would get the same effect here. It's the same thing as the frame count, right? Like I'm just counting one time each frame that I'm drawing my program. So remember that if I had my variable x equals 0, let's say I put it in setup, I'm going to get this error, right? So if I declare x is not defined, and that's coming from my draw function from line 11. So sketch.js line 11, I'm trying to use this x, but it doesn't exist. And so if I declare a variable inside of a function, it only exists inside of that function. So I'll get a different issue if I put variable x inside of my draw function. So the issue that I'm going to get here is that if I declare x, my circle's not going to move, because every time I'm looping back to the beginning of my draw function, I'm drawing the background, and then I'm redeclaring x equals 0, so x is getting set back to 0, and then I'm drawing my circle. So it doesn't matter that I'm incrementing the value of x on line 13, because every time I go back to the beginning of my draw function, x is getting set back to 0. So the way that we can deal with this is we can put our x value into our global scope, or outside of our two functions, the setup and draw function. So now I can create x and assign it a value, but then I can also reference it inside of draw without recreating it and reassigning it. So I could also set it in function, in setup. So I could say x equals 200. And now the circle will start in the middle of the screen. So I can reference x because it already exists. And if I declare x globally, let's put a comment here, global scope. So if I declare x globally, meaning like everything in the program can kind of see this, then when I reference x locally, so this is a local reference, the x that I've created is referring to this x, the x that I'm referencing in setup is referring to the global x. Same thing with the x that I'm referencing in draw. I can create another x, and if I do that, it's going to not work. So if I say variable x equals 200, now it goes back to 0. When I create a variable x inside my setup function, now it's a different x. It's not referring to the global x anymore. So this x gets created inside of setup. It replaces the x that existed globally, but then it doesn't make it outside of setup. So now that change to x doesn't get used by the main program. So it's a little confusing. You may see some issues with that, and that's something that you'll want to watch out for if your variables aren't working for some reason. You may have what's called a scope issue. So you may have a variable that either doesn't exist or is getting redefined or some other issue like that. So it's a little confusing, but you'll get used to it as you use more variables in your programs. So it's just a little bit of a review there. Any questions on the scope? All right, so let's get into our system variables. So we're going to start with static system variables, and static means that they don't change. So once they get set, kind of like our setup function, they're not going to change as long as we're using our same program. So one of the static variables that we have with P5 is width and height. So I'm going to use the console to demonstrate this. So when I create a canvas, the 400 that I put as the first number and the 400 that I put as the second number, these become the width and the height of my canvas. And so I can change those values. Remember, I can change, if I change this height to 600, I'm going to get a taller canvas. And once I create those values, P5 saves them into two system variables. So if I say console.log width and height, you'll notice that it highlights those values with the pink highlight, so it knows that those things exist. So you can see those values are there. And so I can use those values. For example, I can say x, instead of saying it's 200, if I want it to be in the middle of the canvas, I might say x equals width divided by 2. So this will have the same effect. It'll put my circle in the middle of the canvas, but it'll work no matter how big my canvas is. So if I change the size of the canvas to 600, my circle's still in the middle because I'm referencing the width. I'm not using, a hard-coded number. So whatever that width is, the x is still going to be width divided by 2. So it's still going to be half of the canvas. Same thing with the height. So let's add in a y variable. I can say variable y equals 0. And I can say y equals height divided by 2. And I have to remember to use y here. Still using 200. And so now my circle starts in the middle of the canvas, regardless of how big the canvas is. So if I change the canvas to 100 by 100, it starts in the middle. If I change it to 1000 by 250, it still starts in the middle. So using System variables is a way that I can change my program to react to the size of the canvas. And that's going to be really useful because, especially in modern computing, we have a lot of different types of devices. And so you want your program to look the same on a tiny screen or a large screen or a mobile screen or desktop or a TV, whatever it is. We can figure out what is the size of our device by using these built-in variables. And so this is how it works in P5, but pretty much any programming language you're ever going to use is going to be able to reference things about the device that it's on. So we looked at this at the very beginning of the semester, but if I go over to my console, there's other things I can find out, not just about my P5 environment, but about my browser environment. So remember, I had that document. I also have something called the window. And the window refers to my entire browser window. And it gives me all sorts of information that I can use. For example, I can say window.inner width, and that actually tells me the width of the entire browser window that I have open. So any programming environment that you're going to use is going to have some way of interfacing with the hardware that's running it to give us information about that hardware. Okay, so let's turn the canvas back to something more normal. I'll do 600 by 400. So if I try to log the width and the height before I create the canvas, it tells me 100 and 100. So when it first creates the canvas, when P5 first gets started, the default canvas that it creates is 100 by 100. It's not until we tell it that we want it to be 600 by 400 that width and height changes. So we can see the difference if I console log those variables before and after we create our canvas. And if I log those variables before I even make it to my setup function, what we're going to find out is that they don't exist. I get an error, width is not defined. So the values that P5 generates for us don't exist until we actually are using the P5 function. So that also has to do with scope. So we created these global values that we can use in our program. P5 creates local values that are only available inside the P5 function. So I can reference the width and the height. So for example, let's say I wanted my ellipse to be as tall as my canvas. I could say the size of the ellipse is height. I think I have to do height divided by 2, but let's see if that looks right. Oh no, I guess I can just do height. So yeah, it's the full height. So I can still use width and height inside draw, but I can't use it out here. So that's why, for example, if I want the X value to start in the middle of my canvas, I have to wait until I'm inside of setup. So it requires a few steps. I have to start by creating X. It doesn't actually really matter what I assign it here. I can just say that it exists if I want. It'll still work. But I have to at least say that it exists. So I have to say variable X. I can assign it to a value or not. It's usually good to assign it to a value so you won't get an error in case you change something or forget something, but you don't necessarily have to. So then in setup, once I know the width and the height, I can change where X starts. So I can change X to width over 2 and height over 2 to center the values in the canvas that I created. And then when I get to draw, I can use those values as well as the P5 system variable height to actually set up my drawing. All right, so let's get rid of these logs and then we'll continue. You can also use variables for your canvas. So I might be able to say something like this, variable, let's say W for width equals 600, variable H for height equals 400. I can put those variables into my canvas. So I'll get the same result. And so then I could actually do my math here. I can say, well, I'd have to declare W and H first. But if I wanted to, I could keep my math up here. I could say X equals width over 2 y equals height over 2. And now I wouldn't need these anymore. This will still work the way I want it to. Okay, so you can do math in your global variables, but you don't know the size of the canvas yet. So if we want to set the size of the canvas, we can use those hard numbers. But we're going to see an example now where we don't necessarily want to do it that way. So I'll put a comment here, center the circle. Okay. And I just used width, W and H here because I didn't want to, create a conflict between the width that P5 creates and my own width. So the P5 values, since they already exist, we can't use them. If we do, we're going to overwrite them. And that might not cause an issue, but it depends on the value. It might cause an issue. So I'm going to get rid of these and go back to my normal where I started for a second. Okay. All right, we've already covered this stuff. And let's see. Okay, so I guess I didn't get to it here in these notes, but I want to talk about one more thing before we move on. So another thing, there's another value that we can use, which P5 actually takes from the window that I showed you guys a second ago. So if I want to create a canvas that fits the entire available width of my window, I can say create canvas and I can use window width. Okay, so just window width, you can see it highlights it pink, and window height. That's going to create a canvas that's the same size as what I have available. So right here, it's just the preview window. If I make the preview window larger, you'll see it's going to fill it up. If I make the preview window smaller, it's going to be smaller. And then if I use the link, so if I go to share and use the full screen link, it's going to use the full screen that's available. So if I want to size my canvas based on however big the user's device is, I can use window width and window height. That's sort of like in CSS when you say width is 100%, height is 100%, or min width, max width, all that stuff. So depending on the environment and the goals of your project, you might want to use those values. So those are other system variables that are created for us by P5 that we can just reference. Right. So again, we can use these system values to create patterns or make designs based on what we want to see on the canvas. So I'm going to draw a couple more things, and then we'll move on to dynamic system variables. So if I wanted to draw, for example, a grid, I can also use values here. So I already have X and Y. I guess I could just start a new sketch. Let's just start a new sketch. And go to new. Okay, so for this one, I want to draw a grid. A couple different ways to draw a grid. I'm just going to start with a simple grid. So I'm going to do this all in my draw function. I don't necessarily need my variables in setup for this one if I'm just drawing a grid that doesn't move. So I'm going to say variable X, and we'll set that to width over 2. And variable Y equals height over 2. And so if I want to draw a grid, just like 4 quadrants, I can use some lines. So I'll draw a line, and my first line, I want to draw, let's just draw a cross. So I want to start at 0 on X and go to Y. And then I'm going to go all the way across the canvas to width, and I'm going to stick at Y. Okay, so I've got a line across my canvas. Let's draw another line. So this time I'm going to go from the top to the bottom. So the x value is going to start at x now, which is in the middle of my canvas, width divided by 2. And I'm going to start at 0 on y. So you see it's the same thing, but with the values inverted. And I'm going to stay at x because I'm drawing a straight line. And I'm drawing all the way down to the bottom of my canvas. So I'll draw to the height. So we can evenly divide our space to a grid. So again, if I change my canvas, so if I make the canvas wider, I have the same thing, it adapts to the size. So using those variables allows me to adapt to the size of my canvas. So if I wanted to draw these as rectangles, I can do that as well. I can do a rectangle. And so I'll do one in the top left. So I'd start at 0, 0. Oops. And I'd do width divided by 2. So half of the canvas, height divided by 2. Okay, so I've got that top rectangle. If I want to draw a bottom rectangle, I have to move over the same values, right? So you're going to start to see these patterns. So if I want to move over half of the canvas, I have to do width divided by 2 again. Or that's my x value if I want to use x. If I want to move down half the canvas, I have to use height divided by 2. And then my width and my height are going to be the same thing. Width divided by 2, height divided by 2. So now I get that bottom part of my grid. We can do more complex grids, but there's better ways to do it. So we're going to do those ways when we get to them. But again, if I change these values, the whole thing changes. My grid changes, my rectangles change, my line change. So the only hard-coded number is 0 here, because I know that 0 is the beginning of the canvas, the top left. Everything else is a variable. And that's what makes my sketch adapt to the different sizes, because the variables change. It's not like using 200 or 400 or 500. The variables can have different values that change depending on my environment. All right, so now we're going to get into dynamic system variables. Any questions before we move on? Okay, cool. So dynamic system variables are what they sound like. They change depending on different factors like moving the mouse, putting in key presses, time, anything that can change, we can capture with dynamic system variables. So we're going to use our mouse X and mouse Y again. I'll go to a new sketch. So this is mouse X and mouse Y. So these are changing, so I don't have to initialize them. So I can say variable X equals mouse X. Say variable Y equals mouse Y. And now I can draw something using my X and Y. Ellipse XY. Let's put it at, let's make it 50 pixels wide. So now I can move my ellipse around. So the X and the Y values are always changing. The browser is keeping track of where the mouse is on the screen. That's how the computer knows if I click on something or if I'm hovering something. So as I'm moving the mouse, the ellipse XY values change with it. We can actually look at those if we want. We can use our text. So I can say text X at XY. And that's going to show the X value. So if I'm all the way over here, it's 0. Might be kind of hard to see up there. If I scroll all the way over here, it's almost 400. So we can actually see the X value changing as we move the mouse. If I want to show the Y value too, I can add a little comma in there and say X plus Y. So now we see the X and Y value. So the Y starts at 0 up here. Kind of hard to see, but it's up there. And then if I scroll down, or if I move my mouse down, it goes all the way up to 400 down here. So I can use those values that are changing. The computer knows what they are. And as I move the mouse, I can decide where to draw my circle. So if, again, if any interactive software that you use is going to be using this same technology. It's going to be tracking where you move your mouse. I don't actually have to say xy equals mouse x, mouse y. I can just put it directly in here. But sometimes I like to use variables to make it really clear, like what I'm saying is that the x of this ellipse is the same as the mouse x or the mouse y. And then I could also do offsets if I wanted to. Like if I had two ellipses for some reason for my design, I could say, x plus 50. And now I'd have two circles if I wanted to have that be part of my design. So x and y are the dynamic system variables that you'll probably use most of the time. You can also use them. You can put variables really into anything. So for example, this might be kind of confusing, but if I put x for my size, now I'll be moving this circle, but I'll also be making it larger. But it's only mapped to x, right? If I go up and down, the circle stays basically the same size. If I go left and right, it gets bigger because x is getting bigger. I could also say it's x plus y. So now it'll get bigger if I go down and up. I could say it's x divided by y. I probably wouldn't do this, but for an example, so now it's the relationship between x and y. So it's really big over here, and it's really small pretty much everywhere else. So I can use those values for other things, but I don't necessarily want to do that. It's a good idea to label your variables. So for example, if I really wanted to do x plus y, what I would probably do is say variable s for size equals x plus y. So now my variables are labeled and it makes sense what they're doing. And it's okay that they're relative to each other, but it makes a little bit more sense if I have the variable names match what values they're being used for. All right. So besides mouse x and mouse y, we also have something called p mouse x, p mouse y, which is actually a really useful value to have. So I'm going to leave my ellipse here. I'm going to take out this s, or I could just change it rather. I don't need to take it out. So let's change the s back to 50. So besides mouse x, mouse y, I also have something called p mouse x, p mouse y. That's the previous mouse position. And this is really useful for measuring the distance between mouse moves and also how fast. If the distance is larger, we can assume a similar amount of time so we can detect the speed of movement. So I'm just going to draw a line between these to start. So I'll say mouse x and y, and then p mouse x, p mouse y. And so what you'll see is a line. And if I'm moving slowly, the line is very small. But if I move at large increments, the line gets bigger. It's hard to see, so let's slow down the frame rate. I'm going to change the frame rate to like 6. And so now you can see if I move the mouse a lot, I get a big line. If I move it a little bit, I get a smaller line. So that's just the difference between the previous mouse position and the current mouse position. Let's move the frame rate back up. And I can draw a circle there as well. Let's increase the stroke a bit. Do like 6. And then actually let's do no stroke for the circle. And then I'll do no stroke again and do ellipse. So this one I'm just going to use p mouse x, p mouse y. And I'll make it a little smaller so it'll stay on top. 25. Oh, and I have to set the stroke. I say no stroke. Okay. So it's kind of hard to see, but the faster I move, the more difference there is between those 2 points. let's change the color of this circle. Let's say fill is, oops, now we gotta say fill is white here. Okay, so now that's a little bit easier to see. So the blue is the, and let's slow down the frame rate again. I'll say frame rate is 12. So the blue is following behind the white because the blue is the previous mouse position. So that's another system variable that we get from P5 that can be useful. So we also have the frame count. I used this as for a quick demo earlier, but the frame count is just the amount of time that's passed. So we can use that. Let's use that for the size of a different circle. So I'll put another circle and I'll say ellipse and I'll say width over 2. So I'm putting it in the middle of the screen. Height over 2. And I already created X and Y, so I'm being a little lazy here and just drawing this in the middle. And then for the size, I'm just going to put frame count. And so we'll see this circle in the middle just growing and growing and growing as our program is running. And this is just a number that represents how many times we've drawn our canvas. But we can use that to, draw a line or a circle, have some kind of like indicator. Yeah, we could also just draw a line across. Let's try that. Let's say line from 0, 0 to frame count 0. So we'll just draw a line across the top of the canvas. It's kind of hard to see. Let's do stroke weight is. So you can see that line growing up at the top there. So we'll learn more sophisticated ways to do this on Wednesday. But you can start to use those numbers to tie them to, it could be like a loading bar or some kind of timer, a countdown. There's a lot of different contexts where I would want to know how long my program's been running for. And I could use other math to, reset the frame count if I want to. Let's see. Okay, I think that's enough. So this lesson is kind of going over these basics. It's a little more abstract. But I want to give you guys a chance to kind of play around with those values. So for now, you can try adding to your self-portrait. I would make a new copy. So we'll continue. I'm going to show some more examples on Wednesday that are more sort of robust approaches to doing these types of interactions. But for today, just to get started, we've already learned a lot of stuff. So what I would do is open up your self-portrait, and you want to use the one with variables. That'll make it easier to get started. So I'm going to go to self-portrait with variables and make a copy. So I'm going to go to File, Duplicate. And then I'm going to rename this. So this is self-portrait with interaction. And I'll say version 1. Although I guess it's confusing because this is technically version 3. So I'll just leave that. So self-portrait version 3 with interaction. And I'll change the date is 2/28. And let's see. So this is where we left our self-portrait off. And so we have a lot of variables in here already. I misspelled this. Oh, I think I was just demoing this mouth thing. So we already have a lot of variables in here, but you could start to see how you could add in some system variables. So for example, if I change the size of the canvas, my self-portrait isn't going to be centered. So if I wanted my self-portrait to be centered, then instead of saying x is 200, I'd have to say, x equals width divided by 2. So you could start adding in some system variables into your self-portrait with that where you already have some variables to see if you can make some adjustments. You don't necessarily have to center it or do the same things that I was doing, but you might be able to find some interesting things to try with that. So you can try that. And then on Wednesday, we have another section where we'll be going over more ways to do interaction. So there's a few different examples in here that we'll go through. And so you'll be able to control the interactions a little bit better. But for now, you can just experiment with making some changes using the system variables. So let me stop